Welcome back again for part 2 of the PLX. Once again, we have Jonathan Klingen with us, and he's going to dive deeper into the PLX and how it works with the safety equipment. So John, if you could just take it away and show us what you can do here.
What I have here is I have a basic safety system set up. We have a programmable safety controller here with a e-stop and a gate switch. The e-stop is a mechanical contact, or what we call dry contact type of a safety device. It's just mechanical switches that make and break. Dual channel, so there's 2 contacts. And then on the door switch is what we call a solid state device, or it has OSSD signals. They have a little bit of electronics in there, a little bit of brains, really depends on the device. So what I'd love to do right now is to show you the mechanical dry contact piece of it. We look and see how the safety system is currently configured. We depress the e-stop and our safety controller output goes off, just like we would expect. Now keep that in mind, the PLx doesn't give you a pass-fail signal. It's an aid to the safety person to help diagnose and make sure the safety system is A, designed correctly, B, wired correctly, and then finally C, programmed correctly.
Gotcha.
So every system's going to be a little bit different. It's up to the safety personnel to be able to interpret the results.
Okay.
So what I've done with the PLX is we'll reset the e-stop here, safety light comes back on. I've inserted the PLX in series with the e-stop, set of mechanical dry contacts. The minute I inserted it, we had a power LED come on, meant we got system power through, and then we also got our 2 safety signals, channel A and channel B.
All right.
When we depress the e-stop, the PLX, we lose both channels just like we think we should. If one of those lights stays on when you depress your e-stop, more likely something's wrong.
Now, is that typically going to be something wrong within the device itself or the wiring, or?
It could be a combination of a couple different things. If one of the lights stays on, more than likely it's a mechanical failure.
Okay.
It could also be that there is miswired. Somebody wired 2 wires into one terminal. Things like that.
Gotcha.
Now, if both lights go off and your safety controller stays on, that could mean it's also could be a programming problem. Somebody didn't program your safety controller correctly. Okay? So when we reset the e-stop, safety system comes back on, we get our 2 channels back on the PLX. So then we go into actually validating and testing this system. What we can do is we can do a single channel break. So there's 2 redundant contacts in here. So the way the safety system for certain performance levels require that both signals have to be on or off at the same time. So if we do a single channel break, basically we lose one of those signals, the safety controller should be able to pick that up. Okay, so with the PLX, it's as simple as flip of a switch. We flip the switch, the channel indicator goes off, the other channel still stays on, we still have power. But if you notice our safety controller, the safety output has shut off.
Yep.
Okay, so it responds like we think it should. So I restore the channel, comes on here. Notice our safety controller now says, hey, it's flashing red. It's saying there is a fault with the system. I detected a signal drop and then I saw a signal come back. So it's saying, hey, please double check everything before I start back up. So in this particular system, all we have to do is cycle both channels. The safety controller picks up that both channels toggled off and on, and it's able to reset itself. So you could do the exact same test with the other channel, and you should get the same results.
All right, John, so that's one test. What else can you do?
So the PLX can actually also induce cross-short monitoring into the safety system. And what that means is with this particular e-stop, there's 2 sets of dry contacts. Certain levels of safety systems require that the safety controller pick up if those 2 signals get crossed or get shorted together. And that can happen for many different reasons. Somebody wires it incorrectly, or mechanical failure on the machines. A piece of machinery falls and slices the wire, and now the wires become shorted together.
Gotcha.
So the PLX, again, we just do a simple flip of a switch, and that shorts the 2 channels together. Notice our 2 channels are still good here, but our safety controller is now faulted out. Our safety controller is saying, hey, something's wrong, I detected something wrong.
And that's that red light blinking on there.
Correct.
Okay.
Please investigate it. What's nice to show about this PLX is we've shorted the 2 channels together. So now if I do the previous single channel break, I just flip that, I still have 2 lights on. Whereas before we were losing one of the lights. Now if I flip the other channel switch, I lose both lights at the same time.
Okay.
So by inducing that cross short, we've now created a single point of failure into the safety system by only that one channel break.
Wow.
Okay. So we put everything back to normal. We try to reset the system, and we're back to a running state. Okay, so that was the cross short monitoring test.
So that's just been a little bit of what this has been able to do. There's more to it yet.
So a couple of last things it can do, it can induce shorts to ground and shorts to 24 volts. Again, certain safety systems require that the safety controllers pick that up. So we do this on this test again. I will just do a quick short to ground. And notice we lose our single channel again, and our safety controller picked it up.
Yep.
Okay, so I restore the signal, undo the short to ground, toggle it, and we're back to normal state. So what we've done with the PLx testing is we have induced particular faults into the safety system, and based on our knowledge of how the system was designed, wired, and programmed, it responded accordingly.
Okay. All right, so is that all the testing you have for that part of it?
So the PLx has successfully tested and validated the e-stop or the dry contact situation. Now I'd love to show you the solid state device or the OSSD gate switch.
Awesome. All right, so we have round one done with testing on this device over here. Now we're going into round two. So Jonathan, if you'll just take us through this next step of testing here.
So just like the e-stop, we have our gate switch set up on the safety controller for an automatic reset. I've taken the PLx and disconnected it from the e-stop and inserted it into the gate switch here. So just like the e-stop before, we can use the PLx to monitor the safety signals go on and off, and our safety controller goes on and off just like normal operation.
And it senses it pretty quick.
I will run through the same test we did on the dry contact. So we'll do a single channel break just like before. So I'll break channel A, the channel A signal goes away on the PLx. Safety controller also picks up that the channel is disconnected. Okay. So if I sit here and try and reset the safety switch, nothing will work until I get that signal back. Okay. So I restore the signal through flipping the switch on the PLx. Safety controller again says, hey, I noticed something really weird. Check it out for me. So we'll just double check, make sure the switch is working. Safety controller resets because it saw everything is good and how it should be. So the next test we'll do is we'll do that same cross short. We'll short channel A and channel B together. So the minute I flip the switch channel A to channel B cross short, the signals are now shorted. And this is where it becomes critical that the safety professional understand and can interpret the results of what he sees. Safety controller is still on. We have an LED down here on the gate switch that is still green, so it looks like everything's still good. We got both channels here, right? However, we know that this particular set of devices here takes roughly about 20 seconds to pick up a cross short monitoring.
Okay.
So if we sit here and wait a few more seconds, it should detect.
Should be able to detect that and move on, and then what will that do then? Will this change light up green or change to red like it just did there?
So right there it just happened.
Okay.
So the safety controller shut off the output. Also notice our LED over here on the device itself is now flashing red.
That's correct.
So the device itself is now picking up the cross short monitoring along with the safety controller. So I can't emphasize enough that the PLx doesn't give you a pass fail. It helps you interpret the results of your tests. Okay. So I'll take the short back off. We'll try to reset the system. It's not resetting. A lot of differences between the dry contacts and the solid state devices. The solid state devices I like to call as kind of like smart devices.
All right.
So they know something's wrong and they will not reset themselves until you usually power
So a little
cycle.
more high tech, or
That's why you pay the little bit extra money for the OSSD devices, is because they self-monitor themselves.
sounds like it could be worth it though.
So to reset this device, what we're going to do is we're basically going to remove power from the device, and we'll plug it back in. And now the device is reset, safety controller is reset. So that was the cross short between channels, and the third test, just like the other one we did, was short to ground. So we'll induce the short to ground. Notice this time it immediately picked it up. So it faulted out here, safety controller shut off just like we expect it to. We induce the short, or we restore the system to normal. We try to reset. Again, it doesn't reset because the smart logic inside here says something's really wrong.
Don't do it, huh?
No. So we'll power cycle it again to restore it. A couple of these tests that the PLx can actually induce, the faults, could be damaging to particular safety devices. So you got to be conscious of what devices you're hooking to. The primarily ones we see are a set of reed switch devices. If you do shorts to ground or shorts to 24 volt testing, the devices don't seem to like it.
Okay.
Most all other devices we've run across can take those fault inductions without issue.
Wow, there's a lot of stuff that thing can do.
Yes. Like I say, it's a tool, it's an aid for anybody working on the industrial safety equipment, to validate it, to help build it, to help debug it. As a machine builder, as an integrator, we use this on every single safety device on every single machine before it leaves our facility, to validate that it's engineered correctly, wired correctly, and programmed correctly.
So I think could save a lot of potential hazards, we'll say, if you're not doing things properly. Not only that, if you don't know if you're following ISO or anything else in the way that things should be done, and you're questioning yourself, the PLx should take away the question marks.
Exactly. The two most common responses we get when we talk about the PLx to new people is either A, thank goodness we finally have a device that's easy to use and we can just plug in and do things safely. And then the second response, believe it or not, is we should be doing that.
Yeah, I believe it. So I think, as you guys seen here, I think Jonathan did a great job with what he demonstrated. There you go. That is the PLx. So reach out to your local distributor if you are interested in the PLx, or if you have any questions. Thank you for your time today. We greatly appreciate it.